Alright, so in this equation, I'm going to be solving 9 to the power of x is equal to 36. So to start, my variable in this equation is x, which is what I'm going to be solving for. And we can already tell that x is not going to be a whole number because 9 to the power of 1 is 9 and 9 to the power of 2 is 81. So we know that x is going to be somewhere in between 1 and 2. So we want to find the exact value of x. So to do that, what I'm first going to do is take the log on both sides. So I get log 9 to the power of x is equal to log 36. And the reason I used logarithms for this is because they have a special property that states that if I have something in the form log a to the power of b, I can move this exponent b to the front, so this turns into b times log a. So before, x was an exponent, and it's almost impossible to solve the equation just in the form x is. But now we can move x to the front and make it equal to a whole number, and now it's much easier to solve for x. So now I get x times log 9 is equal to log 36. And now, obviously, we want to isolate x, so I'm going to divide both sides by log 9. So then these two cancel out, and I get x is equal to log 36 over log 9. Now, we aren't done yet because we want to find the exact value of x, so we don't want any logarithms in our solution. So now what I'm going to do is I'm going to rewrite log of 36 as log of 9 times 4 because I just want to simplify log 36. And now I can use the property that states that if I have something in the form log a times b, this is equal to log a plus log b. So in this case, I have log 9 times 4, and we can say that a is 9 and b is 4. So this turns into log of a, which is 9, plus log of b, which is 4. And remember, I still have all of this over log 9. Now, if I have something in the form a plus b over c, this is equal to a over c plus b over c, and this is just using fraction properties. So I have log 9 plus log 4 over log 9, and I'm going to rewrite this as log 9 over log 9 plus log 4 over log 9. Now, anything over itself equals 1, so log 9 and log 9 cancel out, and I get 1 plus log 4 over log 9. Now from here, I'm going to simplify this by rewriting log 4 as log of 2 squared, because 4 is equal to 2 squared. And I'm going to do the same thing to log 9. I'm going to rewrite it as log of 3 squared. So now remember that if I have something in the form log a to the power of b, this is equal to b times log a, because I can move b to the front. So I'm going to be reusing this property on these two terms. So log 2 squared, I'm going to move the 2 to the front. And same with log 3 squared, I'm going to move the 2 to the front. So I get x is equal to 1 plus 2 times log 2 over 2 times log 3. And now I can cancel out these 2's. So I get x is equal to 1 plus log 2 over log 3. So now from here, log of 2 is equal to 0.3010, and log of 3 is equal to 0.4771, meaning x is equal to 1 plus 0.301 over 0.4771, which is equal to 0.6309. So 1 plus 0.6309 is 1.6309. So this is my solution. Alright, so in this problem, I have 5 to the power of x plus 5 to the power of x plus 5 to the power of x plus 5 to the power of x is equal to 1,000. So for my solution, I'm going to first start by factoring out 5 to the power of x from my left-hand side. Because as you can see, we have 4 of the same terms on my left-hand side, and the easiest way to go about solving this equation is to factor them out. So I get 5 to the power of x times, well, 5 to the power of x divided by 5 to the power of x is simply 1, so I get 1 plus 1 plus 1 plus 1 is equal to 1,000. And now 1 plus 1 plus 1 plus 1 is 4, so I get 5 to the power of x times 4 is equal to 1,000. Now, we want to isolate x, so I'm going to divide both sides by 4. So then these two cancel out, and I get 5 to the power of x is equal to 1,000 divided by 4, which is 250. So from this large equation here, we got up to an equation that is significantly smaller. So we have 5 to the power of x equals 250, and just at first glance of this equation, we can tell that x is not going to be a whole number, because we have 5 squared is 25, 5 to the power of 3 is 125, and 5 to the power of 4, this is going to be 125 times 5, which is 625. So the value of x is somewhere in between 3 and 4. Now, to actually find the exact value of x, not just an estimate, what we're going to do is rewrite 250 as 25 times 10. And the reason I did this is because 25 is the same thing as 5 squared. So I get 5 squared times 10. And now I'm going to take the log on both sides. So I get log of 5 to the power of x is equal to log of 5 squared times 10. And this is the same thing as, well, log a times b is equal to log of a plus log b. So log 5 squared times 10 is going to equal log of 5 squared plus log of 10. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front. So it's going to equal b times log a. So in this case, I have log 5 to the power of x. I can move x to the front. And I have log 5 to the power of 2. So I can move 2 to the front. And I get x times log of 5 is equal to 2 times log of 5 plus log 10. Now I'm going to divide both sides by log 5, So then these two cancel out, and I get x is equal to 2 times log 5 plus log 10 over log 5. Now, if you guys already know, log 10 is equal to 1. So now I get x is equal to 2 times log 5 plus 1 over log 5. And this is the same thing as 2 times log 5 over log 5 plus 1 over log 5. Now these two log 5s cancel out, so I get x is equal to 2 plus 1 over log 5. And although this is an exceptional answer, I want the exact answer, so I'm going to find the value of log 5. And log 5 is equal to 0.699, meaning 1 divided by log of 5 is going to equal 1.43. So 2 plus 1.43 is 3.143. So I get x is equal to 3.143. And this is my answer to this problem. And remember how we already said that x was going to be somewhere in between 3 and 4. So this proves us right.